On a quiet night, under a clear sky, something extraordinary can unfold. Without warning, a streak of light tears across the heavens, a brief, fiery trail, vanishing in an instant. And then another, and another. To the eye, it's a moment of beauty. To the heart, a flash of wonder. But behind each streak lies a profound scientific tale, one that spans the solar system and reaches across time. These glowing trails are not falling stars, nor omens from the gods. They are ancient fragments, cosmic dust left behind by wandering comets and wayward asteroids. When Earth intersects these dusty trails, the sky comes alive with meteors. This is the story of meteor showers, a dance of debris and fire, a clockwork spectacle of motion and gravity, a story of collisions, chemistry, and light, a story as old as the solar system itself. Every day, Earth is bombarded by millions of tiny particles from space, most no larger than grains of sand. These bits of rock and metal are called meteoroids, and when one enters our atmosphere, we give it a new name, a meteor. As it plummets through the atmosphere at tens of thousands of kilometers per hour, air in front of the meteoroid compresses violently. The friction and pressure heat the particle to incandescence, and for a few fleeting seconds, it burns, tracing a luminous arc across the sky. Most meteors are faint, silent, but during certain times of the year, their numbers surge. These are meteor showers, predictable celestial events caused by Earth passing through trails of debris left behind by comets or, in some cases, shattered asteroids. Each shower has its own origin, its own character, and its own rhythm, like cosmic fireworks with a history. To understand meteor showers, we must journey back to their source, comets. Comets are frozen relics from the solar system's birth, icy time capsules that orbit the sun in elongated, looping paths. As a comet nears the sun, heat causes its ices to sublimate, releasing jets of gas and clouds of dust into space. With each pass, the comet leaves behind a trail of particles. Over centuries, this debris forms a broad, invisible river of dust following the comet's orbit. When Earth crosses this dusty trail, the particles collide with our atmosphere at tremendous speeds, producing meteors in great numbers. This is the mechanism behind a meteor shower, a celestial intersection between planet and comet. The Perseids, for example, stem from Comet Swift-Tuttle. The Leonids come from Tempel-Tuttle. The Geminids, unusually, are not from a comet at all, but from an extinct asteroid-like body named 3200 Phaeton. Each shower is a rendezvous with ancient debris, an annual appointment with a ghostly trail in space. A meteor shower is not a chaotic storm. It is an elegant pattern shaped by gravity, time, and precision. When a shower occurs, meteors appear to radiate from a single point in the sky known as the radiant. This is an optical illusion created by the parallel paths of meteoroids entering Earth's atmosphere, like train tracks converging on the horizon. The location of the radiant defines the shower. The Perseids appear to radiate from the constellation Perseus, the Geminids from Gemini, the Leonids from Leo. But the meteors themselves can appear anywhere in the sky, racing in brilliant arcs. Most are faint. Some leave glowing trails. Occasionally, a bright fireball explodes across the sky, a large meteoroid fragment burning so brightly it outshines Venus. Though brief, these streaks are rich with science. They tell us about particle density, chemical composition, and atmospheric interactions. To witness a meteor shower is to observe the Earth's dynamic relationship with its cosmic environment in real time. Each meteor is a lesson in physics. As a meteoroid enters the atmosphere, it converts kinetic energy into heat, light, and sound. Most particles travel at speeds between 40,000 and 250,000 kilometers per hour. At these speeds, even a grain of sand becomes a glowing beacon. The light we see comes not from the object itself, but from the ionized gas in its wake. A plasma trail created as atmospheric atoms are stripped of electrons by the shock wave. Different elements glow with different colors. Sodium produces yellow. Magnesium yields blue-white. Iron gives off a golden hue. By analyzing these colors, scientists can determine the composition of the original meteoroid. The bright trails, the soft glows, even the occasional crackling sounds, all stem from the raw transformation of motion into energy. Meteor showers are the result of Earth's orbit intersecting ancient dust streams, but these streams are not stationary. They shift over time, shaped by the gravitational pull of planets, particularly Jupiter. Some showers are gentle and consistent. Others, like the Leonids, can erupt into storms, thousands of meteors per hour, when Earth passes through a particularly dense segment of a comet's trail. Astronomers study these dust trails carefully, modeling their movements across centuries. Using computers and mathematics, they can predict when storms may occur, sometimes decades or centuries in advance. These calculations not only help us prepare for spectacular celestial events, but also protect our satellites and spacecraft from potential collisions with meteoroid swarms. It's a reminder that Earth moves through a dynamic, dusty ecosystem of space debris, and that meteor showers are just one beautiful symptom of that cosmic environment. Meteor showers are not new. They have been recorded for millennia, engraved in ancient texts, painted on cave walls, and passed down in oral traditions. The Leonids were first noted by Chinese astronomers in 902 AD. The Perseids were associated with St. Lawrence's tears in medieval Europe. In 1833, a massive Leonid storm turned the skies over North America into a cascade of light, an event that awoke both awe and scientific inquiry. These displays have inspired wonder, fear, poetry, and science. They have united the eyes of kings and commoners alike, watching, wondering, learning. Today, we gather under dark skies not just to marvel, but to measure. We count meteors, track their paths, log their colors, and analyze their origins. Amateur astronomers and professionals alike contribute to our understanding of these luminous visitors. Meteor showers are where science meets spectacle, where motion becomes memory, where space touches Earth, not with violence, but with light. In a world divided by boundaries and borders, the night sky is something we all share. Meteor showers invite us to pause, to look up, to reconnect with the cosmos from which we came. They remind us that Earth is not stationary, but a traveler on a great journey, intersecting paths with ancient dust swept up in celestial currents billions of years in the making. Each meteor is a messenger from beyond, a fragment of a comet's breath, a relic of solar system formation, a silent spark in the sky that says, "You are part of something vast." So the next time you see a meteor, fleeting, bright, and beautiful, remember the science behind the wonder. And know that for that one moment, a tiny piece of space came home.